This presentation we have prepared with the idea of sharing some new stimuli with our students with this very broad issue of water and globalization and scenarios. I will use several times these terms: the globalization, global change. Scenarios. Why? Because possibly one of the main messages of my presentation will be that we are living in a world that is changing, and this happened always, but is changing always in a faster and less predictable way. Okay, so that's why we need to explore the future, actually, and in order to do so, we have to build some sort of scenarios to explain what we know about what could happen in the future. So that's why we have decided about this title, Global Water Scenarios. It has been mentioned already today that, yes, the world is plenty of water, but as Paolo Franceschetti said before, 97% approximately is salt water, so we cannot use it unless we implement technologies like the one you have seen before. And we have to focus all our attentions and also all our efforts for exploitation and valorization, so giving value to water, to what is a very little part of water that is available on the planet Earth, which is less than 1% according to broad estimates. And this less than 1% is mainly stored in aquifers. Okay? So these are, I think, very important figures to give us the idea of what is the phenomenon with which we are confronting today. Probably you are sharing with me now this idea that water is in theory a lot, is available in a very, let's say, huge quantities, but in practice what the water we really need is not that much, and that's why we face competing uses. So competitions for the use of water. Competition is something that has a substantial social and economical meaning, because people can compete raising social conflicts, for example, to have access to the little water is available, let's say, but also, obviously, as you can imagine, people that can pay more can have a greater access or easier access to a resource that is unfortunately limited. So if you look at these figures up there, you see how water is distributed across different sectors, and the main message that comes out of this picture is that, in particular, in low and middle income countries on your right, agricultural uses are the most important ones. Here, coming from an agricultural environment, here there is also a greatest debate about also the term we use. If we had to use, withdrawal, consumption, this is quite a critical issue for discussion. But let's say that the agricultural sector is indeed, from a quantitative viewpoint, the most important one. And why it is the most important one? Because, as you can see below in this picture, irrigation is a common agricultural practice in which you make use of water to compensate a lack of rainfall, let's say, very roughly speaking, that may be in many different places, in order to have a very good production level, okay? And good production level means incomes for farmers, okay? So you see how some countries indeed are using an enormous amount of water for irrigation, and this is obviously raising some conflicts with other sectors. With these pictures, we show just, very introductory pictures about the phenomenon at the global level. But if we go down to some more detailed analysis at the spatial level, we see how not only water is not really available as we wish, but is also showing a very uneven distribution. across the globe. And here we show you a picture that, as you may have noticed, doesn't have the boundaries that we are used to see in our maps. These are not boundaries between states, between countries. These are boundaries between river basins, okay? And so this picture, I think, that show us at least 2 or 3 important messages. When we deal with water, we cross boundaries, okay? So we have a substantial amount of water resources across the globe that is, as we say, a transboundary resource, goes across countries. The second important message that we can see from this picture is that we see red and green, okay? Red and green means places, in this case river basins, where water is available, if it is green, in a way that is comparable to needs. And here comes this notion of scarcity, comparing needs with availability, okay? But in other places you see reds, and this means that there, in those places, water is scarce. Scarce, why? Because either not much water is available and or a lot of water is needed, okay? And here emerges this problem of water scarcity. The third message that is important is blue water, that's what is written below. When we speak about water, we should try to be precise, possibly, and this distinction between blue water, green water, and gray water is another very important message that we would like to share with you today. Blue water is the water that comes from rain, okay? So it's a kind of natural water that flows and is available to us for different purposes. Green water is a kind of water that since it comes from rains, we find it in all our water resources, like flowing along the rivers, okay? And they are usually blue, and we call it blue, okay? But we have also green water. Green water is water that we don't see much, because why? Because it is stored in the soil and stored in the plants, okay, in the vegetation. But this is another substantial amount of water that it's more difficult to catch, but when we make a budget of water, this is a fundamental component, okay? And that's another suggestion for you students to consider very carefully whenever you read papers, etc., to try to be precise in understanding these cubic meters of water, what they are, if they are blue. And then gray water, which is another very important issue mentioned before, that is the water that flows out of some human activities, okay? And this water is usually somehow affected in terms of quality, okay? So 3 main categories of water that we have to bear in mind when we speak about water. Another colored maps. I like usually maps and colors, so I prefer much more than tables usually. This provides us with another message. It's similar to the previous one, but it introduces a new message. As you can see from the legend of the map, if you look at what is shown you in yellow, you see that there is one large area located in particular in Africa where the water scarcity is labeled as economic water scarcity. So this means that the phenomenon has some sort of natural basis, but the way it affects local population is in fact an economic phenomenon, okay? So water in theory is available, but there is not an economic system, okay, in place, infrastructures, for example, to use the water that is theoretically available down there. So this is another example of these interlinkages that are extremely relevant for water resources between nature, humans, and societies, okay? As I said before, these pictures give us an idea of what is the situation, okay? But what is becoming more and more relevant is not the current situation, but the trends we observe and we may observe in the future, okay? So these are the 2 nice colored maps. They show expected trends in the density of population, how much we expect increase, considerable increase, for example, in orange up in terms of density of population located in different parts of the world, and how much we expect in terms of economic development. As you can see, these are, as you know very well, these are two fundamental drivers of many different phenomena, but in particular for today, these are two fundamental drivers in terms of water needs. Okay, so we expect that in these areas, in the coming years, water scarcity problem will be exacerbated by these two trends: growing economy and growing population. Okay, so these are messages that are extremely relevant that we have to catch and to consider in our policies at international level. Still staying in nice colored pictures, but focusing more on trends and agricultural commodities. I think I have justified before the reason why agriculture is relevant for water. Now we can see what are some trends in different regions of the world that are expected in terms of the demand and consumption of agricultural commodities. And we see that East Asia, for example, on top, the histograms on top of this picture, East Asia is showing a very strong potential for the increase of demand of agricultural commodities in the coming years. You see, we start from 1975 and we end up in 2050. And these, depending on the habits, the preferences of population in these different countries, the local demand is different, may change, okay? So in these places, in East Asia, they like pork, for example, and that's why pork, as an outcome of demographic trends and economic trends, is expected to grow very much in terms of demand, okay? What is relevant for us, okay, is that this brings us to a demand of water that is directly and indirectly related to our consumption attitudes and preferences, okay? So this graph, and that's why I put that orange arrow down there, shows us that depending on our preferences, if, for example, we like to eat meat, we have to have some fodder crops available, some plants, some herbs, okay, available to the animals we later want to eat, okay? And that's why if we look at this histogram, we see that, for example, the feed that we need down there in orange for OECD countries, depending on our preferences in terms of food, is extremely relevant and determines, as a consequence, a quite remarkable amount of water needed for our consumption preferences. So we live now in a globalized world, and this is what is relevant, I think, for now. Because we can observe from these graphs what are the main tendencies, the dynamics of some important phenomena in various parts of the world. But at the end of the story, what happens is that humans in different parts of the world, they want to have, they express a demand for something, okay? And the market should provide supply for these demands, okay? So this is very simple, very trivial, okay? If we speak about agricultural commodities and water, it is evident that from the supply side of the thing, we are directly related to fresh water availability, and in turn, we are related to the climate that is in place in the various parts of the world. Climate probably already is significant for us because we are every day listening to climate change as an issue, okay? So again, not only what is happening now is relevant, but also what we expect for the future, okay? And But this is, let's say, the system we are dealing with, okay? As we said before, depending on population, diet, and diet is related to the economic situation of the country, the demand has some specific characteristics. And the issue is therefore to have demand and supply to meet somehow. But in some cases, as we said, demand can be higher, bigger than the supply. So what happens? By tradition, food import happens, okay? So countries are, and this happens at different scales. If in my village I do not have some goods that I need, I will buy this good from the near village, okay? But if I'm not speaking about a village, I'm speaking about a country, I will import agricultural commodities from some other places. And in a globalized world, this happens that, as we will see later, these commodities will jump from a place to another very, very efficiently. But even more, in a globalized world, also other different things happen, which are commonly named now as grabbing. Grabbing means the appropriation of some resource. Quite a lot of interest has been already put on land grabbing. In my opinion, not enough interest is yet put on water grabbing. What does it mean? This means that international companies, sovereign funds, countries in general tend to appropriate resources in other places to solve scarcity problems, okay? So huge areas of Africa and Asia, they have been given, so to say, to the management of foreign institutions, either private or public, to produce goods not for local population, but to be simply used to solve scarcity problems elsewhere. And here is a huge social problem which emerges that I wanted to mention, but obviously we do not have the possibility to go into the details. But what is interesting for us for today is that in both cases we can read and interpret these phenomena by means of some indicators, and indicators are very, very useful ways to provide some concreteness to the issues we are dealing with, okay? And this indicator is named virtual water. What is virtual water? In very few words, is more or less the water that is hidden in a product. Which means that we can analyze and observe these fluxes of virtual water following fluxes of commodities, okay, exchanges of commodities. This is just one of the many maps you can see in various reports showing the main directions, the main fluxes of commodities in which a substantial amount of water is included. Substantial, but how much? Okay, so very careful use of the figures I'm going to show you, but I think these messages are indeed extremely efficient, and that's why we have to use them and use them very carefully. We can estimate that when we purchase at the market 1 kilogram of tomatoes, we in fact purchase also, or somehow within the tomato, is 180 liters of water that have been needed before to produce that kilogram of tomato. Let's move to meat, and meat is a completely different story. So, as you can see, 2 orders of magnitude more water is needed, and in this case, from this source, they estimated 15,500 liters of water needed to produce 1 kilogram of beef. If we purchase 1 hamburger, in the hamburger itself, we can find 2,400 liters of water. Is it true that there is 2400 or are they 2000 or more? Well, obviously this is not that relevant for now, but what is important is to have the perception of how much water is needed to produce some kind of commodity that we purchase, okay? And at the end, as I showed you, this activates a lot of fluxes of water hidden somewhere. So, trying to be brief, I think that regarding this first part, I hope that I could share this message with you. That is, water is in fact everywhere. This is not strange, but what is important for us is to have the knowledge and possibly a quantitative knowledge of what is happening, okay, and what it means, what we observe every day in the market, okay. So what is the mechanism that is behind and the possibility we have to introduce, possibly, as I will mention later, some sort of efficiency in the system, okay, which is indeed more and more needed because we are facing more and more scarcity problems. The second important message that I would like to share with you is now still regarding trends, but in particular, regarding what you can observe up there in terms of, this is a logarithmic scale from the past 100,000 years ago up to now, okay, present, and these are various phenomena like temperature anomaly, cropland allocated, water withdrawals, CO2 emissions, total material consumptions. Okay, so what is the message of this chart? The message is that we have observed in the past for sure some cycles, but a relative stability. And when we move up to 1960 here, we see that all these trends are somehow diverging from some sort of stability that we may have observed in the past, okay? So what this chart, I hope, shows very clearly is that world is somehow moving out of what was the usual avenue, okay? And this is something we have to consider carefully. And this is also what several people are now describing as the Anthropocene. So a sort of a new era, a sort of geologic era, okay, in which humans are becoming the main players in the evolution of the planet Earth, okay? And this, I think, is a very important. The same message or similar message we can derive from many other pictures that we can find everywhere. Okay, if you look at here the FAO Food Price Index, you see that it was relatively stable with some sort of tendency towards a decrease in the price of agricultural commodities over time until we reach the new century. Okay. Here some signals, okay. Now a big jump in the nominal or real value, real price index of agricultural commodities around 2007, 2008 in particular, and then these graphs that start jumping somehow, okay. So it's a sort of phenomenon that used to be stable and now it fluctuates. It's not the time now to go into the understanding of how this could happen, but we could mention, for example, the relationship between the market of agricultural commodities and the financial market in an era, in a time that, as you know, has shown here a substantial financial crisis. Okay, this is the so-called hockey stick graph. Okay. And this is well known everywhere. It shows us the concentration in the northern hemisphere, CO2 concentration. This is temperature, okay? And this shows again that the temperatures has fluctuated a lot over the last 10 centuries, and now it jumps, okay? Similarly, we can see for the number of natural disasters a tendency towards kind of growing phenomena, faster dynamics, more instability. And this, I think, is the second main message that I would like to share with you, the instability of the system with which we are dealing with. and the uncertainty that is associated to our efforts in understanding this instability and how the system behaves, okay? Just to be on the science side of the thing, we can, if we speak about water security, which is a burning issue, fortunately we see that also science is more and more focusing on these problems, okay? Numbers of publications per year in this, around these issues were very, very little before the year 2000. They are growing more and more. So we should be positive, I believe, and hope that science can also provide solutions very, very soon for these problems. Science has then obviously to make these available to policymakers, and this is another issue. So a few slides more before concluding. This is a selection of messages coming out of the UNEP Global Environment Outlook 2012, in particular GEO5 publication. I put in bold some important keywords. First of all, water use efficiency. The needs of water not only for us, but also for our ecosystems. And here we have another greatest issue. The planet Earth cannot function without ecosystems, okay? And we benefit a lot from ecosystems. If ecosystems are disappearing or are not working as they used to work in the past, we have to surrogate this, and this costs an enormous amount of money, okay? Point and non-point pollution, so pollution of water in general is the greatest issue. Water supply, and it was mentioned before, so sanitation as the two main issues focused, for example, in the Millennium Development Goals. And this introduction of a new dimension, which is what we call the climate-sensitive policies. So those policies that should include consideration of global change and climate change in particular into business as usual. And the need for governance, obviously, to manage all of these things. So just to consolidate a little bit these messages, a few slides just to a quotation, for example. This is a paper from some colleagues in agronomy where they were focusing on the efficiency of irrigation system, and this is another message that we can read in many, many places. We could save at least 30% of water if we could make our irrigation system to be more efficient. But what is the main message here is that we cannot focus only on one of these components, because since this is a product, okay, if one of these efficiencies is equal to zero, the whole process has an efficiency equally zero. And the message for today is that we should not focus only on what we used to focus in the past, but we have to include more efficiencies in our considerations, okay? For example, the efficiency in transportation of agricultural commodities, the maps with those arrows that I showed you before, the efficiency in the market, the efficiency in consumption. Another big issue is the waste of food that we make, which is again being estimated in the order of even 1/3 of what we purchase, okay? Pollution is, as I said, an issue. Fortunately, again, just to be also have some optimism, we can see that in Europe the trends in terms of pollutants are usually decreasing, apart from nitrates in water. And some very interesting initiatives. Here I mention this initiative, the climate change adaptation strategy in Denmark, which is very, very proactive. And I extracted this sentence, as you could see. In practice, this project for climate change adaptation in Denmark will contribute methodologies and input for how municipalities can work with conflict management, player preferences, and possible incentive structures. So, again, we could speak hours about this single sentence here, but just to mention the fact that when we have to put in place and in practice these general concepts, we have to move to a very local scale, okay? Municipalities, as you can see, where we face all these problems of preferences, conflicts, and so on. Just to come back to our place, also another initiative that we had recently concluded, the idea of taking advantage of information and communication technologies, okay? So we have, this is a recent research project that we concluded in which we used the internet to set up communication means with farmers, have interviews of farmers to have their perception in terms of changes, what changes are in fact in place, and what are their reactions, what are their opinions in terms of what may happen in the future, and setting up a communication means to, for example, at the end of the story, collect their preferences in terms of where to focus more, and this is the final histogram showing the preferences of several hundreds farmers who participated in our project. For example, the preference is expressed to invest, to focus more, to use the little money we have in investing in irrigation methods with higher efficiency as compared to other possible strategies that we may implement. Unfortunately for our interests, climate services, which were one of our flagship, if you like, they are not on top of the preferences of our farmers, just as a final joke, if you like. Okay, so I think you've taken the final remarks from here, so probably I don't need to go to some final remarks because we will have a sort of final discussion where we will share these final remarks, and so that's time for thank you for your attention. Okay?